All right, let's get cooking. Thank you all for coming. This is Inside Kubernetes, an architectural deep dive. I am Anthony Nocentino, enterprise architect at Nocentino Systems. Since this is the first session of the day, I will actually read through all of these slides. Please silence your cell phones. And also explore everything PAS has to offer. I've been engaged in the PAS community for the last couple of years, so I've had the opportunity to engage in each one of these things that the PAS community gives you to work with. So 24 hours of PAS, local groups, SQL Saturdays, fun stuff like that. So please engage with the community and volunteer if that's something that you enjoy doing. Session evals. I am an engineer. The only way that I get better is with feedback. So please fill out the session evaluations. I believe there's a QR code somewhere in this room or outside of the room that will help track my data down. And I would love to hear what you think about today's session. Mostly what I want to hear is that your brain hurts a lot, because hopefully it will. So I am Anthony Nocentino. Like I said earlier, I work for Nocentino Systems, where I am a consultant, trainer, and founder, and all of that fun stuff. I specialize in system architecture and performance. I like to design systems. I like to make things go fast. I've been a data platform MVP for the last couple of years, and a friend of Redgate, who is a lovely sponsor of this event. Go see them at their booth. There's my contact info. It's going to show up again later. Please reach out to me if you have any questions, any follow-ups, things like that. I'm going to give you the code at the end. I think it's attached to the conference website, so you can download it. If you get in there and you have any questions, feel free to hit me up. I blog pretty frequently at that URL there, and I'm a Pluralsight author. A lot of today's content is based on a series of courses I've done at Pluralsight. I have free trial cards right here for you all if you want to have 30 days free access to Pluralsight, so you can go visit this content and kind of learn more. I think I'm up to about 18 or 19 hours of Kubernetes content on Pluralsight. And please follow me on Twitter. It's my main way to engage with the community, because I live in the middle of nowhere and have no friends. Just kidding. And I work from home. So we're going to cover a lot today. If you've never used Kubernetes before, that's cool. If you've used Kubernetes before, that's cool, because we're going to start from nothing and kind of walk all the way up. I would think some pretty advanced topics. So first, we'll start off with what is Kubernetes, and then we'll go into the benefits of using Kubernetes and how it can provide value to you and the applications that you deploy. Then we're going to learn about the Kubernetes API objects. Kubernetes gives us, literally, objects that we can model systems in code. And that's kind of the culmination of what we're going to do today, is we're going to have code that we can hand off to somebody else to deploy a system. And we can manage this code in a way that's different than probably how we're used to managing systems over time. We're going to look at Kubernetes architecture, look at the inside and learn how it makes decisions and things like that, so we can learn, kind of like to learn the internals of how things work. So when something goes wrong, I know where to look and troubleshoot and things like that. We'll look at deploying a general or generic web application. And of course, since this is PAS Summit, we'll talk a lot about SQL Server. About half of today's session, we'll talk about specifically how to deploy SQL Server in Kubernetes. And if you were in the keynote this morning, or you were been paying attention on Ignite, or on Twitter at Ignite, or if you were at both, that's cool. We're going to talk about the future and how this is kind of the underlying substrate of what's coming next in our data platform universe. And so it really kind of starts off with this container-based application deployment, right? Over the years, things have really changed in how software is built and shipped, right? We started off in a place like this with single-tier applications. Jokingly, I like to say anything that was written by IBM, right? Because if you've supported an IBM product, you know exactly what I'm talking about. But the idea behind this is I build this big thing, this code or this package or this software, and then I have to ship it out the door and I have to give it to my customer, and my customer has to put it in production, and that takes a lot of time, right? And it's hard to service that. How can I quickly deploy something, especially like 10 or 15 years ago when I literally had to like burn it to media and ship it out the door. And so things have changed over the years, and we've learned better techniques on how we can get code from a developer's workstation into production faster. And one of those techniques that started that was multi-tier applications. We started to break things up into more functional components, with the primary reason of being able to change things faster without breaking stuff, right? And that's kind of the core element there. I want to be able to get code into production without having to ship a giant monolithic thing. And then over the last couple of years, in the buzzword bingo, it's this thing called microservices, right? Where we took that paradigm even further and zoomed it down to more functional levels and how we can roll out apps. And that's where containers started coming in. It gave me, or not me, it gave us the ability to take units of code from developer workstations and roll that out into production. But then that left us with another challenge. If I needed to build some sort of multi-tier web application and get those things into production in a container-based way, I have some things I have to think about before I go about doing this, right? Where do I run these applications, these container-based apps in my data center. Like if I have a collection of resources, CPU, disk, RAM, virtual machines, physical machines, whatever it is, where do I stand up that container in that collection of resources? Do I want to get in the business of making the decision within the collection of these resources? Do I start this container there or that container there and get that workload up and running? That can be hard to do, right? How do I scale this application? What if I have to go from 2 web servers or web front ends or verse proxies, whatever it is, to 20, to 100, or anything like that? What if I need to respond to a business event, maybe at the holiday season, where I need to sell more stuff, right? How can I grow my application quickly so that I can consume those resources? And how do I do this consistently? How do I take a multi-tier architecture like this, where I start breaking it down into more functional components, and deploy this consistently? Can I deploy this in another cloud, in a down-level environment, at my DR data center? How can I take that and do that somewhere else over and over again, especially as we get into even finer-grained microservices that we're drilling down and maybe having web servers and web services that are even broken down further into individual units, and I'm using content routing and all that complex stuff. And then how do I access these applications? How do I point users at the web front ends? How do I point the web front ends at the caching tier? How do I point the caching tier at the data tier? How do I solve these challenges when I'm deploying containers in a data center or in the cloud or wherever that is, right? And that's where Kubernetes comes in. We have one slide about Kubernetes. No, I'm just kidding. This is the only one. And so Kubernetes, I like to say, has one job, right? And that is to start containers. But really, it's this idea that it's a container orchestrator, right? Where do I start that container in my data center? Do I have access to the resources that I want to have access to run that application in a particular way? And when we're working with containers, specifically in Kubernetes, we're going to use this construct called a pod, right? And a pod is your container-based application. Who's worked with Sql Server and a Docker container? About half, right? So by the end of today, we're going to use Sql Server in a pod. We're going to use that as our method or our abstraction of deployment into our Kubernetes cluster. And now, Kubernetes also gives us the ability to, I really want to tell a sidebar joke, but I don't have enough time for that, but hit me up later, about infrastructure abstraction. We're going to care less about where we deploy our application and focus more on how we deploy our application. I don't really care so much, do I need a public IP, or is it going to be on this server over here? Is my LUN landing on that particular SAN over there? I don't have to worry about that anymore. I'm going to write code that says, run this application, run this many copies of this application, give me a public IP address, and maybe if I need it, attach some storage. We're going to do what's called a declarative model, where we're going to leverage the desired state of our application. So I'm going to write code. I'm going to say, hey, Kubernetes, do these things. Run 2 web servers, a caching tier, and a data tier, and just keep that up and running for me all the time. Figure out where to run it in my collection of resources, and just go. If I skew from that state, maybe a node dies, maybe an application crashes, Kubernetes will just fix that for me. We're going to learn the technologies and techniques on how it solves those challenges today. And so some of the benefits of Kubernetes is this, right? And I kind of said Kubernetes has one job, right? Starting containers. Well, more precisely, it has the responsibility of managing state, right? I tell it what to do, it starts things up, and it keeps them up for me. It also provides speed of consistency and deployment. Again, if you've started Sql Server in a container or any container-based application, it's comically fast, right? You can get a Sql Server up and running in a matter of seconds. And I can do that over and over and over again, because I'm going to write code to do this for me. We're going to write a declarative code that says do these things. It also allows me to absorb change quickly. You're going to see me do a demo later when I get to the demos, where I take a single tier or single web application, scale it from 1 to 3 to 50 application servers, one line of code, in about 3 seconds, right? If you were in the business of selling stuff and your company had a website that a bunch of people were going to, in fact, you can make Kubernetes scale for you automatically. And you're going to see in this demonstration where we can scale our application out very, very quickly and react to those changes. And scale back too, so we can save money. It also gives us the ability to recover quickly. We're going to learn a little bit later. I'm going to crash Sql Server, and by the time I run the command to query Sql Server the second time, it will be back. Right, because Kubernetes will keep track of the state of my application. I can attach health checks and other advanced techniques to make sure that my application is responding correctly. And we're going to learn some of those techniques today as well. It also hides complexity in a cluster. Again, I've kind of beat home the point of we're not going to get in the business of saying, run this pod on that server with this public IP, and maybe they have to register these IPs in this load balancer and do all of these things. That's all going to be handled for you. And it's going to be in a way that I think is really, really, really elegant. And finally, it provides persistent application access endpoints, right? So I will point users here at this particular endpoint, Kubernetes has the responsibility of distributing that workload to the application pods that support it, and I can go about my day focusing on how to run my application, not how to run the infrastructure underneath my application. And so I've used this term already a little bit, this concept called a Kubernetes cluster. And a Kubernetes cluster is literally just a collection of resources in your data center. So servers, virtual machines, physical machines, the CPU, disk, and RAM that makes up the resources that you have available. You aggregate that all together, and we're gonna leverage Kubernetes to consume these resources in a particular way. And so in the end, we're gonna have something like this, where I come along and just say, hey, Kubernetes, do these things, and it's gonna figure out where to run those apps and stand them up for me, give me an access endpoint, and I'm just gonna point users to those applications and go. And I make it sound trivial. It really will be that simple once you kind of start getting into the techniques on how this really works. Oh, also questions throughout. If anybody has questions, it's cool.
The Kubernetes cluster is a concept or is a physical server? Or?
Good question. So the question is a Kubernetes cluster a logical or physical construct, right? Yes. And so So the cluster is going to be kind of like a wrapper around the resources that are available to me, and we're going to learn now how we interact with the cluster to make it do stuff. And so you get away from the idea of worrying about the individual nodes, because they just worker bees, they just do work for you, and you address the cluster universally and ask it to do things. And we'll learn about scheduling and things like that in a little bit, where Kubernetes will make the decisions on where to place workload. Good question. All right, so now that we kind of know what Kubernetes is, let's learn about how we can tell Kubernetes what to do. Right, we're going to learn about the Kubernetes API. And so there's this thing, or this collection of things called the API objects, which represent the resources available to us in our system. It's the stuff, right? And we're going to interoperate with this thing called the Kubernetes API server. And that's going to be like the main communication hub for us to interact with Kubernetes and for all of the nodes that are part of a Kubernetes cluster to interact with the Kubernetes as they change state information or exchange state information and other things like that. Now, the core API objects that we're going to work with are things called pods, controllers, services, storage, and a lot more. And we're going to focus on these four today, right? We're on pods, which is your container-based application. It's literally going to be a wrapper around a container and all of the runtime information it needs to know for it to execute successfully in your cluster. A controller is the way that we implement desired state. If I tell Kubernetes, I need you to keep up one SQL Server all the time, 2 web servers all the time, I'm going to wrap that up in what's called a controller, and it's going to affect that desired state for me. Services provide IP and DNS for persistent access into our apps, and storage is where we store stuff. So literally, if I want to attach a block device, a network share, whatever it is, into my Kubernetes pod, I can do that. And these are kind of the core fundamental building blocks of applications inside of a Kubernetes cluster. Pods being our apps, right? Literally the containers. Controllers being the desired state. Hey, Kubernetes, do this. Services, access. Storage, being able to store things over time, which is really important to DBAs because that's how we stay employed. Now, there are many other Kubernetes objects available to us to do other types of work. We have cron jobs, we have node and route controllers, all of these different things to help model more complex systems. But again, these are the core building blocks and the ones that we're going to focus on. Today, we're going to start off with pods. And like I introduced already, it is your container-based application. And there is a possibility that you can have one or more containers in a pod, right? You're going to see commonly you have one container per pod. But there are design scenarios, and it's really specific to how you deploy your application or your application's architecture, where you could potentially have multiple containers inside of a pod. Generally speaking, if there's a real tight producer-consumer relationship between your app and whatever other pods or containers you need to put in that pod, you would put those two things together. So think of your application might emit like some log, and you have some sort of log processor, maybe a performance monitor container inside of that pod working together. The anti-pattern to that would be, some folks ask, would I couple a web server with a database server inside of a pod? You wouldn't want to do that because your pod is really going to be the most basic unit of work, right? It's going to be the unit of scheduling and also the unit of scalability. So if I have a pod with multiple containers in it, and I say, hey, Kubernetes, scale to 3, to 5, to 10, does it make sense to have an application with a web server and a database server in a single pod scale? How do I copy that, right? So you break that dependency, scale the web services or web servers independently from the data tier, right? And in SQL Server, it's a little challenging to scale in that sense, but in other data platform technologies, you can do that not want to say easily, but you can do that. Now, this is trippy. Pods are ephemeral, right? No pod is ever redeployed. A pod is always recreated. And so this really means we have to decouple configuration and state from our application, right? And we're going to work with a stateless application initially today, and we're going to work with a very, very stateful application later on for the second half of the presentation with Sql Server. We'll focus a lot on that. But know that if I destroy a pod or Kubernetes comes along and destroys a pod due to a controller operation, if that pod gets recreated, we're always going back to the starting state of that container image, right? So I have to assert configuration externally or manage state for my application data externally to that pod. And we'll focus a lot on those techniques as we go through the session today. So controllers help us. It's like a little latency there. I'm gonna talk to my network people. No, not you. That was supposed to be a joke, but then I realized it could actually be. So anyway, so controllers have the responsibility of creating and managing pods for you. So we're going to come along and tell Kubernetes, you know what, I want you to do this, right? I need you to affect this desired state. I want you to run 3 copies of this web server all the time. And if you skew from that desired state, I want you to fix it. And that's what controllers provide for us. Controllers also respond to pod state and health, right? So if my application, I can add additional health checks to my application to check for an HTTP return code. I can execute an arbitrary program and interrogate the exit code. I can attach a listener for a TCP port. And if I skew from that state, Kubernetes has enough information to make a decision, right? It could do something. It could kill my application and redeploy it. And that's where going back to that original container or that original state provides a lot of value, because if I know my application at this point worked, if I deploy a new one, well, I know it's going to work when Kubernetes automatically makes that decision to kill my application and redeploy it for me. Now, the 2 primary controllers that we're going to work with today are going to call what's called a replica set and a deployment. I did not mess up the font on that. That's intentional. That's a fixed width font because that's the actual Kubernetes API object type that we're going to work with, the deployment and the replica set. And the replica set is the controller that has the responsibility of implementing the desired state of an application. So for example, when I keep saying, like, I need you to keep 2 copies of this application online, that's the responsibility of the replica set in Kubernetes. But we don't get in the business of creating replica sets directly in Kubernetes. We create deployments, and deployments create replica sets. And what that allows us to do is to move between versions of replica sets in a very easily and declarative way. And so if a developer comes along and says, hey, I have this new version of my application and I need you to roll it out, I go to Kubernetes, I change 1 line in a YAML file, I run a command, and I've rolled that application out. Whether it's 1 pod, 100 pods, 1,000 pods, and I can affect that change very, very quickly. And we're going to see that in a little bit in some more graphical representations, and we're going to do that a lot in the demonstrations today. Let's just say like a database engine was released on Monday. So services are the way that we access these things. So we kind of talked about pods, right? That's our application. We talked about controllers, how we keep things up and running. And services are how we're going to get people to access the stuff that matters, right? The applications that we want to deploy. And so if I have a controller that's reacting to application state, or I come along and I scale and contract my application, I make these changes, we don't want to get in the business of tracking the IP addresses of all those individual pods that are working to do this thing for me. And so what Kubernetes does is it puts kind of a wrapper around all of that and gives me a single IP address, and it has the responsibility of distributing that workload to the underlying pods that are part of a particular service. And so we get this concept of a networking abstraction for access to those pod-based applications, right? So, and we're going to get IP and DNS for this. So we'll get an IP to point users to or to point our applications to, and whether it be for caching and data tiers or things like that. And we'll also get internal DNS so we can reference these things by name. Services also provide rudimentary load balancing. So if I scale out my application or contract it, I don't get in the business of having to re-register and deregister IP addresses. All this happens under the hood for you automagically. And it's about that awesome, because automagically being the right term to describe it. So yeah, and as we recreate, or as Kubernetes recreates pods, all of this information is going to be updated for us automatically. And so like I said before, we're going to do a demonstration where I take a web application, scale it from 1 to 3 to 50, and I don't have to go log into a load balancer, make a configuration change. It just works, and we'll get into the internals of how that all happens when we get into the presentations. Yeah, so scale by adding and removing pods. Cool. Any questions? Awesome. All right, so that's kind of the core way that Kubernetes does its thing. So we introduced kind of the benefits of Kubernetes, then we kind of walked through kind of the core concepts, pods, controllers, and services. We'll focus on storage when we get into Sql Server. Let's look at a little bit closer, kind of to your question, what happens inside of a Kubernetes cluster. And so there's this thing called a master, right? And the master has the responsibility of coordinating the work, right? Kubernetes is a container orchestrator. And inside the container orchestrator we have, or inside of the master, more precisely, we have an API server, right? This is a container, or a pod, actually, that we're going to interact with. That's a RESTful, JSON-based API server, get, set, post, all that fun stuff that we're going to interact with to affect change inside of the cluster. And so since it is also stateless, so it has what's called a cluster store to store the information or the changes that we make to our application state. So as I inject configuration, I interact with the API server, and that information gets persisted into the cluster store, which is conventionally etcd, which is a key value data store, but also could be Cosmos DB, which trips me out. I'd love to be able to experiment with that because you instantaneously get DR, global replication of a critical resource that you'd have to make sure is protected in various ways because it does persist the state of our Kubernetes cluster. We have the scheduler, which has the responsibility of figuring out where to run our workload. So as we inject changes, the scheduler will make that decision for us, and the controller manager has the responsibility of maintaining a desired state. If it skews from a desired state, the controller manager is going to say, you know what, you told me to run this many pods, go ahead and create another pod. Or if I had too many pods, it'll contract back in a scale-in operation, the controller manager having that responsibility. Now, we're going to use a tool called Cubectl, or Cubectl, or Cubectl. It's a hot topic of debate to interact with the cluster, but I'm going to say Cubectl, and I expect all of you to say Cubectl. So we're going to use Cubectl to interact with the API server. It's going to be our command line utility to do stuff. And so that's going to be how we affect change. So we can do it both imperatively and declaratively, where I just execute commands and change things, or I can feed in declarative configuration files in YAML or JSON. Now, in addition to the master node, we will have a collection of worker nodes that are the actual compute resources to do stuff. And inside of there, we're going to have what's called a kubelet, the kubeproxy, and a container runtime. The kubelet has the responsibility of interacting with the API server. And so the kubelet will poll the API server looking for state changes. The kubeproxy has the responsibility of networking on the local node. So if I say, hey, I need you to expose this application on a particular port on the network, the kubeproxy has the responsibility of implementing and affecting that change on the local node. And the container runtime has the responsibility of starting up the container and keeping it up and running on the system. The container runtime conventionally is going to be Docker, but could be other container runtimes. If you're in AKS, it's Moby, and Rocket is another container runtime that's available. But chances are it's going to be Docker. So like I said, Kubernetes has one job, right? Starts containers. So all of that stuff that we've been talking about has the responsibility of communicating to the container runtime to do something, right? But there's other stuff. I have to bridge things onto the network. I have to attach storage and affect all of those changes. And so that orchestration is why Kubernetes has become valuable, because it does those things for you automatically without you having to worry about all those things. And so let's look at kind of a controller operation, right? So let's say we come along and I said, hey, Kubernetes, I used Kubectl, and I'm like, I need you to run 3 copies of this web application. I rolled out a deployment, and I just said, hey, run 3 pods for me. And so I communicate with the API server, which persists that information into the cluster store. The scheduler makes the decision on where to run those pods in the cluster and distributes my workload like this, right? Clearly a simple example, but this could be more complicated depending on things like affinity and anti-affinity and other scheduling concepts that exist. And so in this case, we distribute this workload, and let's say something bad happens. Maybe there was a network partition, right? Maybe the node crashed, or maybe that pod just died altogether by itself. And so what's Kubernetes going to do right here if I told it to run 3 pods of this particular application? It's going to spit out another pod, which is really, really cool because I didn't get paged and I'm still asleep. And then I can wake up in the morning and go, oh, look at that, and go figure out why my node died and have to go and put my cape on and figure out what broke, right? Who likes getting paged? Who uses the term paged anymore? I just totally aged myself, right?
Firefighters, doctors,
Yes, yeah. I've worked in hospitals, yeah. Medical professionals and doctors still use pagers because of signal penetration. You have a question?
Yeah, so are there something else that you have to manage on your end, or is that something else that Kubernetes also spins on?
So depending on, so the question is, maybe repeat it back, is who manages the nodes from like an OS infrastructure standpoint? Is that it? Okay. So the idea is a node is just compute, so it still has an operating system, and conventionally it's going to be Linux. There is a concept of Windows nodes now that GA'd recently within the last 6 to 9 months. But the majority of the container universe being Linux. So you still have to get in the business of patching the node, updating the drivers, treating it like an operating system. But from an application infrastructure standpoint, you kind of pull back a little bit. And so you can kind of treat these things as worker bees, right? And so I can pull this one out, throw it away, and drop a new one in and be kind of autonomic in that sense. And so something that GA'd this week in AKS is node autoscaling, where I can expand the physical virtual machines in Azure and get those compute resources for me automatically. And we'll talk a little bit about managed service providers and things like that at the end. But yes, you still have to take care of the OS and care for it and feed it and love it like you would any other application server. So yeah, in that example that I did a second ago, you saw that when I recreated the new pod, the question is, can a pod run on a master, yeah? And so in that example, I showed when the pod was recreated, it went onto another worker node. And so by default, when you create a Kubernetes cluster the way that I did with a tool called kubeadm, which is kind of a on-prem cluster, the master is what's called tainted, and so that means from a scheduling standpoint, it's not going to accept user pods, but it'll run system pods. And so all those components that were inside of the master node are called system pods and are tagged a special way that allows them to run on the master. You can untaint your master and then run user pods, but that's not a good idea in production. But in labs and things like that, it's totally valid. Good question.
I'm trying to compare this to Windows Server cluster.
Mm-hmm. Okay, I see what you're saying.
But what happens if you lose the master? Do the rest of those keep working?
So the question is, what happens if the master dies? So if the master dies, let's say like the master just crashed, rebooted, whatever, the workload is fine. You can't inject any additional changes though. It won't, things won't just fall over and die for all of your worker nodes. So it's our responsibility as engineers to make sure that we protect the master. And there's two things that we care most about. I talked a little bit about etcd, right, which is the cluster store, that database that needs to be protected from a backup and DR standpoint. And then access into the API server, since that's a stateless application, can actually be scaled out linearly with multiple API servers pointing back to a single cluster store. So there are different design patterns for making highly available masters, but the two things, no matter how you fry that fish, the two things you have to protect are the cluster store and access into the API server, your state and your ability to make changes. But if it dies, your workload's still fine. So good question. So services, let's get into that a little bit and watch kind of how the magic comes together. So we're going to zoom out from the worker node. Hang tight for 1 second, please, sir. We're going to zoom out and look at this from a cluster level and focus on services. And so if I came along and said, hey, Kubernetes, I need you to create 4 pods for me for this particular application. And what we're going to do is we don't point users at the pods, right? They're going to have their own IPs and listen on ports and things like that, but things can be shutting down and moving and changing based on application state. And what we're going to do is we're going to front end that with a service, and we're going to define that with a TCP port or UDP port and protocol and port, excuse me. And then we're going to point users at that. And so then what Kubernetes is going to do is it'll take that workload from the user and distribute that to the pods internally for me automatically, right? Load balancing. This is super fabulous because when something like this happens, what's going to happen is Kubernetes will deregister that pod from the load balancer for me automatically. Since we've wrapped that up in a replica set, what's Kubernetes going to do? It's going to kill that pod and redeploy it somewhere else in our cluster, and it's going to register the endpoint of that pod into the load balancer again. I'm back to where I was. I have 4 pods up and running and supporting my application, and again, I didn't get paged. I'm still asleep. I wake up in the morning and I go, oh, that's cool. And this happened, right? I think that's pretty cool. Y'all think that's pretty cool? Yeah? All right, cool. Let's take that even further now. So deployments. Now, if I say Kubernetes, I need you to run a particular version of my application. I'm going to create a deployment, which has the responsibility of creating a replica set. Replica sets have the responsibility of creating pods. And so in this case, I said, hey, Kubernetes, create a deployment running V1 of my application and stand up 2 of those pods in a replica set, right? I'm going to front end that with a service, expose that on a particular IP and port, and I'm going to point users at the application, right? So now my developers come along and they're like, you know what? V1 was cool, but let's roll out V2. right? So we're going to make a configuration change inside of our cluster, one line of code. This is crazy when you see this for real. I'm going to change one line of code, and this happens. Kubernetes will create a new replica set. It will start up the pod, running version 2 of my application, register that pod's endpoint into the load balancer, and start distributing workload to it. It will continue that pattern until I'm on the final state of my application. I just had a 0 downtime rollout. Who would like that? I like that, right? Of course, we have to deal with application architecture, data structures, compatibility, all of those application-specific things. But after a while, you're going to engineer for this design pattern so that you can roll out without breaking your application or taking downtime and things like that. One second, sir. And with that, then we still also have the old replica set available to us. So if something did go bump in the night and I need to roll back to V1, because that never ever happens, I keep the metadata about the old replica set around and I can roll back, right? And so that transition is managed for me. Actually, we had a question in the back, and then I'll go with you. Sir, do you want to ask your question again? This one? Yeah, Node, yeah.
Sorry, okay. So my question is, one of the nodes went down. Kubernetes was supposed to create 3 pods, 2 on one of the nodes and the other one on the one that failed, but instead it created it on that one node that was working.
Correct.
So I mean, do we need to know? So yeah, it's working, but how do we get notified the second node was not working, or, you know?
So the node failure would be
the node failure.
Yeah, the node
does
failure
it
would
get
be the
notified, or?
responsibility of your monitoring infrastructure to say, hey, something that did go bump in the night.
Okay, so that's not part of the Kubernetes.
Yes. Yes, we're going to do Sql Server. The question is, in addition to rolling out applications and changing versions of our applications, can we do patches that way? And we're going to specifically do Sql Server that way when I get into the demos. So one last question, and I want to get going, because we have a lot of content.
Can the Kubernetes be used for the DR solutions?
I'm sorry, can you repeat that?
Can the Kubernetes be used for the DR solution, disaster
DR?
recovery?
Yes, there's a concept of I guess you could say multi-zone or multi-tenant clusters across clouds and things like that. You can go into design and things like that. But generally speaking, you'll keep a cluster contained within an individual data center region, things like that. And you use for me, I would use other technologies and techniques to DR into other sites. So, okay, we got that. We did deployments. I love deployments. I have fun customer stories about that. So, deploying applications. So now that we know what a cluster is in Kubernetes and all the benefits and awesomeness, and we know how to communicate with the cluster and kind of the core constructs, right? Controllers and deployments and pods and things like that. How do we tell Kubernetes what to do? And we can do that in a couple of ways, right? We can do that both imperatively and declaratively. So I can execute imperatively a sequence of commands to change my cluster state. Hey, Kubernetes, do this. Hey, Kubernetes, do that. And execute those commands at the command line to affect those changes. But I can also do it declaratively, right? And this is where I want to be when we're deploying and managing our application state, is we want to do these things declaratively. I'm going to write code that describes what I want Kubernetes to do, and Kubernetes will just go do that for me. Hey, run 2 web servers, a caching tier, a database tier, attach some storage over here, expose an IP address over there, and let me access my applications. I don't care where you run it, just make it happen for me. And we can do that declaratively. And if you're a T-SQL person, or if you've ever written T-SQL, you're familiar with this paradigm. You don't get in the business of telling Sql Server how to read the data off the disk, right? You just say, hey, Sql Server, give me this information from these tables and filter it this way, right? So it's the same concept in that way, where you just say, hey, I want this to happen. And the 2 predominant ways that we're going to do that declaratively in Kubernetes is with YAML and JSON. And jokingly, I like to say people speak YAML, computers speak JSON, right? And so we're going to predominantly work with YAML today, but in the end, Cubectl is going to convert that to JSON and inject that into the API server to affect that change when I say, hey, Kubernetes, do these things, right? And so let's walk through what's called a manifest, right? A manifest is going to be a collection of YAML that we're going to use to communicate with our Kubernetes cluster. And bear with me, we're going to walk through this code line by line. It can be a little laborious, but it's important because this is how we're going to communicate with each other when we exchange these configurations. And you go online and look at docs at Microsoft.com, and you see how applications are deployed. And so we're going to walk through this in pretty gory detail. And so the first line of every manifest in YAML is going to start off with this, what's called an API version. Right? An API version gives me the ability to say, hey, when I have an object, it's going to look this particular way all the time in this version, which means Kubernetes can come along and the maintainers can introduce a new deployment or a new pod, and that'll be some other version of the API. And this is completely independent to the actual system software of Kubernetes. And kind of the DBA analog here is compat mode versus running an actual version of the engine, right? I can change this out when I want, and I can change out the engine when I need to. And so whenever I'm ready to take on that new version of a pod or a deployment, or whatever it is, then I can go and change that code. And there are some guarantees about how long these things will last in the life cycle in the Kubernetes project. Now, the kind is the object, right? It's a thing I want Kubernetes to do, right? In this case, it's going to be to create a deployment. We're going to have some metadata, which is going to be something like a name, right? Hey, do this thing, right? Of course, we have to have a hello world application. Now, the spec is going to be the technical specification of the object, right? And so all Kubernetes objects have these four things: an API version, a kind, a metadata, and a spec, right? Which API version? What am I going to create? I give it a name, and now I'm going to go into kind of the gory details about what a deployment consists of, right? Hey, create 3 replicas. I want to have this thing called a selector. A selector is going to have a match label, and a match label is going to have a key and a value pair that's going to define what I want to be a part of this deployment. And so think of this as kind of like a predicate on a query, right? And I'm going to assign some labels to the pods that are created by this deployment so that I know that these pods are a member of this particular service. Now, we don't get into the plumbing of actually making sure that that changes, and that's going to happen for us automatically. But labels and selectors are a way that Kubernetes can do all of those things automatically, like, oh, these pods are a member of this service, right? And so this, the selector is the thing that says these are the collection of pods that are part of that thing. And so now we have what's called the pod template, right? So we just defined what the deployment consists of, right? 3 replicas and a label selector that looks like that. And now we'll have a template that says what pods are going to be created or stamped out by the replication controller or the replica set for this particular deployment. We're going to assign some labels to those, so each one of these pods will have that same key and value pair. And then the spec for the pod itself. And so now I'm going to get into the application-specific stuff. I'm going to say, hey, I'm going to run some containers of this particular container image. So that's coming from the Google Container Registry. And it's going to be a simple hello world application with a tag of 1.0. And then I define the name. And so this is kind of the bare bones minimum way to deploy an application in a deployment inside of Kubernetes. Because we're not going to get in the business of creating pods independently with this concept what's called a bare pod, because if we do that, if something breaks and that pod dies, well, there's not something monitoring it to recreate it at some other point in time. So even if you do have to come along and create a single pod, you're going to want to do that in a deployment so that if something goes wrong, Kubernetes can just fix that for you if that's how you want to maintain your application. So this top part, kind of zoom out a little bit, is the kind of the deployment definition, and the bottom part is the pod template, right? The thing that gets created over and over again by Kubernetes. I write that stuff into a text file. I save it into something like deployment.yaml. I say kubectl apply -f, and I feed that into the API server, and Kubernetes goes and makes this happen. And so by the time I hit enter, a few seconds later, we'll have 3 copies of our app up and running with a load balancer and all this fun stuff. And so let's go ahead and do that. We're going to go ahead and imperatively deploy an application into our cluster, and we're going to access those services. What's up? Do we have a question? Oh, you're right behind the speaker.
So in that spec for the pod, can you tell the pod how much compute you want it to be able to consume at a maximum?
Absolutely, yeah. I don't go too far into this concept called limits and requests. It's very similar in VMware, where you can say I can always have this much memory, or I can never have below this much memory, kind of an upper and lower bound.
There's like reservation type values.
Exactly.
Okay.
Yeah, in both terms of CPU and disk, or CPU and memory. Excuse me. Yes, in fact, So the comment is, the cluster will use those limits accordingly. So yes, it uses those in scheduling decisions to make sure that when that workload gets distributed to a node, that node has the resources to actually run that thing. So for example, if I create a pod with a request of 4 CPUs, and if I don't have anything with 4 vCPUs in my cluster, it won't get scheduled. It'll just go pending install. There are defaults. I don't remember the exact defaults off the top of my head. Memory has no limit, and I think CPU is 1 or no limit. I have to double check. There's a very easy way to do that with a command called Ctl explain, so I can go and see what the default values are. But I don't have time to get into that today. But if you want to, I can show you definitely afterwards. But good question. So the first set of demos that we're going to do, I'm going to do imperatively, even though I preached the whole time about doing this declaratively, but I'm just going to show you how to stand up some workload. And at the bottom of this demo, I have all of the declarative configs for this particular demo. And so to interoperate with the cluster, we're going to say, hey, Cubectl, right, I want you to do something, create a deployment, and I want to give it a name, hello world, and I want you to run a particular container image. So here we're going to have our hello world application up and running. So let me kind of resize the screen a little bit. I'm going to highlight the code, and it's going to run on the bottom, kind of like SSMS. So here you can see deployment apps, hello world is created. And so I created a deployment, which created a replica set, which created some pods, right? And so my deployment is named as hello world. I am up and running on the latest version of my application, so I have ones across the board. I have my replica set, who has the name hello world with a pod template hash ending in C68, which has a desired state of 1. We have 1 current and 1 in ready, meaning the application is responding appropriately. Now here is the listing of all the pods. So we see the deployment name, the replica set pod template hash, and a unique identifier for the individual pod, and that it's up and ready and running. So I know my app is happy, but I haven't defined any health checks. So really all this means is my pod is running. And so my application could be floundering, but that's a whole other show. Good Eats reference there. So Cubectl expose deployment is how I'm going to let Kubernetes expose an IP address for access into that pod-based application. So I say Cubectl expose deployment, which deployment hello world. I'm going to point users to port 80, and the load balancer has the responsibility of pointing the workload to the container port 8080, which is what the actual container is listening on. So I run this code here, and I get an IP address inside of my cluster that I can point users to persistently. So this will persist for the life cycle of the deployment object, or excuse me, of the service object. So yeah, so Cubectl get service hello world. So I'm going to do some command line foo to put that IP into a variable so that I can reuse it over and over again. And so my application, which I'm going to access via the command line web browser curl, doesn't do anything other than say hello world, because you have to, version 1, and then gives me the host name or the pod name of the particular application pod that's running up in my cluster. And right now I have only 1, right? Cool, let's do this. Cubectl scale deployment hello world replicas 3. If you've ever worked in IT ops and you had to clone a virtual machine, to do that 3 times, you'd still be typing the ticket up, right? And then you have to go and make a block level copy of potentially a 60 gig virtual machine, maybe go edit a load balancer configuration. I did it in 1 line of code, right? Bang. 3. That's cool. Access my application again, 1, 2, 3. I'm getting load balanced across all the pods, right? To me, that's quite dramatic. And it's one of the reasons when I saw Kubernetes for the first time, I'm like, yeah, that's going to be a big deal, all right? That's only 3. All right, so now we're going to see another thing. We're going to tell Kubernetes to roll out the new version of our application. Remember the rollout strategy that we saw in the presentation? Kubectl record, because I want to keep track of the metadata of this operation. Deployment set the image for the deployment hello world for the container hello app equal to version 2.0, right? The tag at the end there, 2.0. So I'm rolling out hello world 2.0 with some new advanced features. If I do a git deployment, I'm already up and running on the new version of my application because I can see up to date is 3, right? So it's shut down in an ordered fashion, shut down a collection of pods, started up a collection of pods, worked through the whole set, and brought them all up on the new version of my app. So by the time I do this, we have our new blistering holiday functionality of hello world 2.0, right? All right, let's do this. Scale to 50. And by the time I do this, you'll see container creating, you'll see running. I now have 50 application containers up and running supporting my workload. I didn't have to touch a load balancer. I didn't have to clone a virtual machine. And I can distribute that workload for me automatically. So all the pod endpoints get registered into the service. Workload gets distributed. If an application crashes, we recover. This is dramatic stuff to me. Like, I get really excited, which is, I guess, kind of geeky. But it's all good. He's excited. I'm excited. We're all excited. So with that, I can go ahead and clean up. I'm going to delete my service, delete my deployment. So 1, 2, so we can very quickly get rid of our configurations, which is good or bad, depending on your perspective, and it'll start going through and kind of collecting the resources and getting me back to that new desired state, which is a desired state of nothing. Now, the rest of this demo, I have the same stuff, but declaratively, right? And then we're gonna, in the SQL Server side, we're gonna do everything declaratively. And so let's go ahead and shift gears. You'll have all of that code available to you to repeat that demo, both imperatively and declaratively if you want to. So I think that's a pretty dramatic, that's about as dramatic as you can make Hello World be in a conference setting. So running SQL Server in Kubernetes. This is past summit. We have to talk about SQL Server. I think it's in my speaker contract. But we have, we have to deal with something now, right? If it's a stateless application like Hello World, and I start up a new pod, well, I'm just going to go back to that starting application state. And in SQL Server, I have to deal with some stuff, right? In terms of configuration and state, right? My actual data. And so where do we store the actual stuff, like databases in this world, or if I just delete the pod and it comes back, it's going to be recreated? Or if I have to inject some configuration, how do I go about doing that? You have a question?
During the demonstration, you created one container and many replicas of the container, right?
Correct.
What happens if you have many different microservices to compose the application, and each one of these microservices has a different need of deployment schedule, but at some point you need to deploy all at once? How do you manage the file with the script for deployment?
So that's, from a coding standpoint, is, I don't want to say like a matter of perspective, but that's going to be how you enjoy writing and styling your code. So I like to kind of keep things separate based on their physical resources, and I focus predominantly in the data platform universe. So I don't have a ton of experience in a microservices world, but if I were to do that, I would probably break it up by application and group those things together, or the resources associated with those applications. You wouldn't have like a big monolithic file that describes your entire application stack, right? You would make it in a consumable, manageable, changeable way that you can most effectively manage your environment, right?
Life cycle.
Yes, Dave, thank you. So configuration and state, right? These are the two big things that we care about as DBAs because data keeps us employed. So this is going to get crazy. So we're going to think about this concept here. This is like my favorite slide. So we're going to decouple data and computation, right? And so we're going to use that design pattern. We're going to roll out SQL Server in a deployment and expose it with a service. But we're going to make a subtle change to that in a second. So I say, hey, Kubernetes, create a deployment which creates a replica set running some version of SQL Server. We'll say version 1, right? And then we attach some storage, which is a construct we haven't talked about yet, but we're going to focus on in a little bit. That storage can persist outside of the life cycle of the pod. So if I come along in SQL Server and I expose it as a service, and if something happens to SQL Server and that pod dies, or maybe I accidentally delete it, or whatever it is, Kubernetes has the responsibility of putting a pod back for me and attaching the storage. SQL Server starts up the application process. It's like, hey, where's my master database? It's right there on my storage. Oh, inside the master database is all the entries for my user databases. They just happen to be right there too. I have my application state managed between the lifecycle of a pod, or independent of the lifecycle of a pod now, which really becomes a liberating way in how we can manage SQL Server over time when we'll start talking about things like version upgrades and patching and redundancy. So if I come along and SQL Server crashes, oh, we already covered the crash error. If I come along and say, hey, maybe on Monday a new version of SQL Server came out, that same way that I changed that deployment in a single line of code, I can do that for SQL Server too, which will instantiate a new replica set. It'll shut down SQL Server. It'll move the storage. It'll start up a new pod for me in this other replica set. All the endpoints will be deregistered and re-registered in the IP load, or in the load balancer of the service, and I get a quick transition between the two versions of my application, right? And that can happen in a matter of seconds. we still have to worry about moving between things like 17 and 19 or whatever versions of SQL Server it is. That still exists with database versions, but between CUs, this can be a very powerful way to roll out and manage patching of our SQL servers, again, in one line of code, being able to affect that change. And I also get the high availability and all that fun stuff that we talked about from a pod state and health standpoint. If SQL Server gets sad and decides to crash, it will just come back. And we're going to do that in some demos. And so we're going to talk about storage now and how we can expose storage into our cluster. There's these concepts in Kubernetes called persistent volumes, which really are just administrator-defined storage, right? It's some stuff that I can have in my data center in the cloud and attach that to a container or a pod over time, right? Independent of the pod lifecycle. So it's going to be something like an iSCSI LUN, NFS mount, Fiber Channel, Azure Disk, Azure Files, whatever that is, right? There's dozens of potential persistent volumes that you can consume. But we don't get in the business of wiring a persistent volume directly into our pod configuration, because if you notice, those technologies are very infrastructure specific, right? So we're going to come along and have what's called a persistent volume claim that allows us for the pod to make a claim on the PVC, and then the PVC is mapped to a PV or a persistent volume by Kubernetes. And what this does is it gives us the ability to decouple the pod configuration from the infrastructure specific details of that specific persistent volume. So kind of to your point about, from a microservices standpoint, to kind of extend this into the data platform world is, how do I kind of affect this change and kind of make my code reusable independent of the infrastructure that it's on? So the code that I'm going to give you guys today, or you all today, is going to be specific towards my NFS server, which is really great for me, but not for you, because you don't have an NFS server in your test lab. So I also have additional code that allows you to create pod infrastructure in Docker for Windows or Docker for Mac, so that you can create the same infrastructure on your laptops or in Azure or whatever that is. Meaning in just having to change out that one little unit that is the persistent volume definition. And I'll show you that when we get into the demos. So yeah, PVC will be declared inside the pod. Now, to go further, and I kind of described this a second ago, is data persistency specific to SQL Server, right? And so we go about creating these persistent volumes and persistent volume claims. And what we're going to do is position a persistent volume at a specific location in the file system, right? And on SQL Server on Linux, we're going to put that at var opt MSSQL. And what that means is a block device will be mounted, or a share will be mounted at that exact file location inside of the pod. And the kubelet has the responsibility of orchestrating that work inside of the cluster to make sure that my persistent volume is on the node when that pod starts up, so it can access that location. As SQL Server writes data, it thinks it's writing it to var opt MSSQL, but it's really writing it to the block device or whatever network share is implemented in the persistent volume. And we're going to see that in some demonstrations in a few minutes. Yeah, var opt MSSQL. Now, user databases land here by default, but you can build more advanced disk topologies if you need to. So this would be for the instance directory, but if I needed to go about building something where I want to have data over here and log over there, or multiple volumes to stripe things out, I have a blog post that kind of describes that detail, how you can go and build these more complex disk implementations. And I also did a session for the past HADR VC where I walked through all of that in person, or in video on YouTube now. So configuring SQL Server. So we talked about state, right, and how we manage that over time for SQL Server. We store our data in persistent volumes. Now, how do I affect configuration, right? Because I want to decouple all of these things, so SQL Server just kind of becomes a cog in a machine that I can kill and redeploy when I want to. And so if I want to configure SQL Server, we still have the concept of going back to the initial state on pod creation. If I want to configure SQL Server, the primary way that we're going to affect configuration state inside of a pod is through a concept called environment variables. And so when SQL Server starts up, it's going to read the environment variable and affect that change for me, right? There's other more advanced concepts, things like config maps and whatnot, that can help us do more advanced configuration. But the dominant way, and you're going to see this a lot in the examples on docs.microsoft.com and other things like that, are going to be leveraging environment variables. And so my brain totally just rebooted. Yeah, so when SQL Server starts up, it's going to use these to configure the instance. So if you've stood up a Docker container before, you've done this, right, where you've defined these two environment variables. You have to accept a EULA because of, you know why. And you also have to inject an SA password because we have to put that into the master database to store that over time. And so as SQL Server starts up, accept a EULA, read the SA password, store that in the master database, which is going to persist on our external volume. Now I've decoupled configuration and state, and I can kill it and redeploy SQL Server completely independent of that. Now, there are dozens of environment variables for configuration. I don't know if it's one-to-one, but pretty much anything that was in SQL Configuration Manager is exposed or surfaced as an environment variable. But I don't know if that's 100%, but I do have a link here to all the environment variables that you can use to inject configuration into SQL Server when it's running inside of a pod. Lots and lots of fun stuff there. So let's deploy SQL Server. This is like the fun stuff. And we're going to do that with persistent storage. So let's go ahead and jump over here. And I have all of this code available for you. Let me go ahead and make sure that I'm starting from a known good starting point. And the very, very first thing that we're going to do is I use environment variables a lot, so that I don't have to type things over and over and over again. But I'm going to go ahead and set my password as an environment variable so I can reuse it. And I'm also going to store it in a cluster as what's called a secret, so my applications can reference that to affect that configuration without having to inject a potentially sensitive piece of data into a YAML configuration that I might give to Dave here, who's totally untrustworthy, to roll out in his production system, right? But I want to be able to share my configuration with him, right? And so I'd give him the code that can do that. So let's go ahead and run that code so we can see the secret is created. And I'm going to roll out all of my storage and my SQL Server in 2 lines of code. Create storage, create SQL Server, right? That's pretty cool, because now I don't have to go and clone a VM and get an ISO and install SQL Server and patch the heck out of it. I'll have SQL Server up and running in a matter of about a second or 2. So with that, let's go ahead and look at those configuration files. So storage.yaml is going to be the description of the storage devices that I'm going to be surfacing into the pod. So here we have, what does every YAML file have? API version, kind, metadata, and a spec, right? So we see persistent volume, we give it a name, and I have a spec. I have a capacity of 10 gigs and an access mode of read write once. And so in the concepts of working with a database engine, read write once means that only one node can mount that persistent volume at a point in time, which is really, really important because I don't want to have another node come along and mount that volume at the same time. That would be bad news in a relational engine. If I delete the volume, this is kind of a safety net. I set it to retain, so if I delete the volume, it doesn't torch the actual volume or the data on the volume. And now we see the technical implementation details of my NFS server. I expose that, or I surface that as a claim. So here we see persistent volume claim. I give it a name. I give it an access mode and a request. Persistent volume claims are mapped to persistent volumes on those 2 attributes, access mode and capacity. All right, so that's my storage configuration. My SQL Server configuration is here. API version, deployment, metadata, spec. I want this deployment to always keep one SQL Server up and running at all times, which is really cool because you're going to see why. I'm going to use the recreate update strategy, which is an update strategy that shuts down SQL Server before it starts up the other SQL Server. The default is rolling update, which would start, if this SQL Server was up and running, it would start that one and shut it down, which is really great for stateless applications, not so great for stateful applications. But SQL Server handles that because it can't get an exclusive lock on the file when it starts up master, but it'll crash and it's just not fun. We'll jump down to the spec. We have a container whose name is MSSQL, and we're going to run CU15 of 2017. That's going to be on the container port of 1433, which is inside the container. And then I have accept EULA with a defined explicit or a value here of yes, an SA password, which is going to read its value from the secret key ref, where the secret key is MSSQL, and I'm going to read this particular key to surface that SA password into my configuration of my app. So I don't have to actually have that code here, so I can give my code to Dave without worrying about him knowing what my password is. Volume mounts, MSSQL DB, and I'm going to mount the volume at this location. So no infrastructure-specific stuff here, right? It's totally agnostic of that right now. This volume mount is going to reference this volume down here for the persistent volume claim. That is the one that we created in the other file, right? And so I keep those 2 separate. So I can just give you this file and just say, hey, all you have to do is create some sort of PVC with that name, and it'll just figure out where to allocate that storage internally. We then expose our application on a service. So here we see API version kind, metadata spec for a service. We see a selector for MSSQL, which is determining who's a member of this particular service. If we go back up here, we'll see our label app is MSSQL. So that's how it determines that this particular pod is a member of that service. I'm going to expose that on 31433 to the container port 1433. And if I want to have multiple resources in a single file, 3 dashes. All right, so that was SQL Server rolling out. I also have, like I said, the Docker implementation that lives in this folder if you want to do this in Docker for desktop. And we'll talk about that a little bit more later. So let's do a belt and suspenders check. Do I have a pod? Yes. SQL Server is up and running. So there's our deployment, this particular replica set, and it's going to run, or that particular unique pod identifier. So let's go ahead and see. We have a service. Go ahead and grab that and throw that into some environment variables and ask SQL Server, what's your name, what's your version, CU15 2017. So even though it took me 3 minutes to kind of walk you through all the code, like I said, if you had to do this with templates in VMware, you'd still be copying a block level device because that's about 60 gigs at a minimum for a base OS image running SQL Server. Let's go ahead and add a database. So SQL CMD, create database test DB1. That's like the database version of Hello World, right? Thank you for laughing. Now, the storage, right, we decoupled the computation from the storage, right? And so the storage isn't going to be where the pod is. There's going to be some level of indirection. And the kubelet has the responsibility of exposing an NFS mount into SQL Server. The actual data lives on my NFS server, which is C1 storage 1. And just to go look there, we'll see that's where it created the instance directory, and that's where all the databases are now. So we see master, tempdb, testdb1, all of which were created just a couple of seconds ago when I started up this demonstration. We started from a blank slate. But if I deleted SQL Server right now and started it back up again, it would go and attach that volume, read master, and have all of those databases available to it in a location that it thinks is var of MSSQL, right? If I just ask SQL Server for the physical name of sys.master files, all that's happening for me under the hood. So this could be Azure Files, this could be Azure Disk, maybe not files, Azure Disk, or some other storage device that I could expose into SQL Server. So that's the storage story. Let's talk about the recovery story. Who's familiar with shutdown with no wait? It's a really good way to make SQL Server sad really, really fast, right? It's like pulling the plug and starting a process over without doing all the good stuff that it should do when it shuts down. So I just crashed SQL Server. Let's go ahead and use my favorite Kubernetes command. If you have any problems doing something in Kubernetes, kubectl describe. What do you want to describe? Some object type. And that's going to be pods. In this case, the ones that are a member of a deployment. And so I deployed SQL Server about 6 minutes ago. And so yeah, we have some additional errors. And then we see it's successfully assigned. So 6 minutes ago, it successfully assigned this pod to one of the nodes in my cluster. And then 19 seconds ago, because this is showing us that this entry happened twice, when I crashed it, it's like, you know what? I already have that container image. Just go ahead and start that container back up. And so by the time I do this, I already have SQL Server back after I did a shutdown with no wait. I didn't have to do anything. Like, it just recovered because I told I told Kubernetes to make sure that I always want to have one SQL Server up and running at all times. It just reacts the right way. Now let's go so far as to delete a pod. So I'm going to say kubectl delete and then the actual pod name, which is going to shut down the pod gracefully, right? Then delete the definition of this particular pod. So I want you to take a guess on what Kubernetes is going to do after I delete this pod. Right, so it's going to create a new one. So kubectl, get pod, so I get a new pod, deployment name, same replica set, or pod template hash, new identifier, right? FRBDD, I think that is, and the old one being JCCHH, right? This is where it gets cool. So I'm going to query master files again. All of my data is still there from a few minutes ago. Tempdb, or master from before, and testdb, right? So just totally threw SQL Server away, and it's like, you know what? That's cool. Here's a new container image. Start it up. Mount the data. Go, right? That's pretty awesome. Let's do some more awesome stuff. Let's roll out CU16. kubectl deployment set image. Which one? The MSSQL deployment. I'm going to change the container image of MSSQL. I'm going to roll out CU16. It's going to run that code. Yeah, I think I got it, but it like scrolled off. So you can see image updated. I can ask Kubernetes for the status of a rollout with kubectl rollout status. And this is going to be kind of a real-time monitoring of the state changes, right, as it rolls out my application. In more complex scenarios where you're changing out hundreds of pods or thousands of pods at a time, this can be a valuable way to keep up with that state change. So here we see successfully rolled out. What's my favorite command? kubectl describe. What do I want to describe? A deployment. And here we can see the state transition between the two versions, right? Our initial replica set, which 8 minutes ago ended in 7BB, scaled to 1. It shut down that one because we changed the update strategy to recreate from rolling update, and it started a new replica set and scaled that up to 1. Right, so here we can see I have both replica sets still available to me, the new one ending in B58 and the old one ending in 7BB, but there's no pods running in the old replica set. Go ahead.
When you shut down SQL Server Kubernetes, it's just checking if the SQL Server process is running. In
that specific case, is the container running?
Can it be more intelligent login? How long did it take me to log in?
You can define a health check, which can call an arbitrary executable. If it returns a known exit value, you can interrogate that exit value.
Okay, thank you.
So, all right, so I just updated it from 15 to 16. 16. You'd still be downloading the patch, right, if this was Windows. No offense. I mean, I love Windows. So, I'm going to get in trouble. So Ctl Logs. So if something goes wrong, so after Ctl describe, if something goes wrong, Ctl Logs is going to be the standard output from the container that's running. So I'm going to say Ctl Logs and then the pod name. And I'm going to get the standard output from that pod, which in this case is going to be your SQL Server error log. So if something does go bump in the night during that upgrade, you can go and interrogate this and get the information to help you troubleshoot what you need to troubleshoot. Most common thing that's going to break when you do this for the first time is your password's not going to be complex enough. You're going to do Ctl Logs, and it's going to tell you your password wasn't complex enough. I do it all the time. All right, that's cool. So I used that -- record option when I changed out the version of my application because I wanted to track some additional metadata about those state changes of the deployment. So I can ask Kubernetes for the rollout history of my app. So here I see version 1, my initial deployment, and here I see version 2, where I can see the actual change that occurred. So guess what I'm going to do now? Undo deployment, roll back to version 1. Shut down CU16, start up CU15. That's crazy, right? So by the time I go down here to hit describe deployment and go and interrogate that information about that, this should all kind of come back. We still have to run the upgrade scripts to go back to 15. So that can take about a minute, but here we can see the scaling operation of scaling down our replica set. They're scaling up. Add at server name. Awkward. No, I know what's happening. It takes a second for it to get the pod started, get the storage attached, start up the process, and now we can see that we're in upgrade mode. So this is just a matter of time before we get to a known state. And so if we do this, -- follow, we can actually follow the progress of the update transition if that's what we need to do, right? Now that's not just for CUs. We can actually roll out a new version of SQL Server, because let's just say a new version of SQL Server came out earlier this week. And we can roll that out in the same way. Of course, we have to worry about database ID. We have to do all the testing. We have to do all those things that we would normally do when we stick the, we stuck the DVD in the server and upgraded SQL Server, or however we did all of our upgrades before, right? That stuff still exists. But we can affect these changes a lot more easily in this paradigm. So yeah, now we're on CU15. Let's roll out that. And I don't have a Cubectl describe here. Cubectl describe. Don't type in demos. I'm just going to go and copy and paste that. That's another story. All right, we'll do that another day. But the idea there is we can roll that out very quickly. That, I know what that is, and that's a problem that I need to address. But I'm going to go ahead and clean this up, and we're going to run back into the presentation portion. I'll debug that before I publish the code.
DDL changes for your versioning of apps being released. If there is a DDL dependency, are you going to cover today?
So in that scenario, you still have to manage that state. That's a state transition of your application, which you'd have to manage externally. I'm kind of focusing on the system elements at this point in time. But yeah, if I needed to change a data type or add a new table, that's something I'm going to have to manage externally. You can bind those two together. You can deploy like jobs in Kubernetes to execute arbitrary tasks. You could do that.
Understood. But I was wondering about when you were releasing your version 2 application, like a little bit earlier in your demo, where you were saying it's like, hey, I'm keeping everything. You do need a SQL Server, which your version 2 app is dependent upon a particular column being in there. How do you do that?
That's going to go in your application architecture. You have to manage that state transition on your own. There's a gentleman named Kevin Fiesel who has a fantastic presentation about zero downtime upgrades that covers all of those topics specifically. I don't think he's doing it at Pass Summit, but it's on YouTube and it's available, and it goes through those use cases in gory detail. Let's chat afterwards because I want to get through the next bucket of content because I think we're kind of in the red zone from a time standpoint. So who's seen this picture? Right? And jokingly at the beginning of the session, how many times did you hear the word Kubernetes this morning at the keynote? Right? Apparently I have to do 6 shots later. But big data clusters, right? We're not going to talk about big data clusters and all the internals and things like that of the goodness that a big data cluster is. But if you look at this picture now, you know what a lot of the infrastructure components are behind this platform, right? You know what a persistent volume is at the bottom. You know what nodes are and pods and all those things. And this is how Microsoft is building their next generation data platform, is on these things. Right? And the idea is because they're going to write the code to give to you to run in your Kubernetes cluster. And they can still control in the most positive way the configuration and state of their applications and just publish code to you to consume. As long as you have Kubernetes, you can do these things. They just ship code to you. It doesn't matter anymore what the infrastructure is. It does, because David Klee would give me the stink eye if I said it doesn't matter what the infrastructure is, but you get the point. So this came out earlier this week, Azure Arc. Guess what Azure Arc is built on? Look at what step 1 is of an Azure Arc deployment. Have Kubernetes in your infrastructure, right? Again, Microsoft is leveraging Kubernetes to be able to provide advanced data services to you in your own data center because they can just hand you configuration and all you have to do is have a cluster to be able to do these things, right? And kind of decoupling those applications and state and all that fun stuff that we talked about today. They're going to use those same constructs to build and design systems to deploy to you and to be able to give you these larger solutions than they've been able to do in the past. And so we've covered, I think, a pretty good bucket of stuff today. We did, so what is Kubernetes, right? We kind of know like the value that it provides, the benefits. We covered kind of the core objects, right? Deployments, pods, persistent volumes, storage, services, all those fun things. And we looked kind of inside at what the architecture is from a scheduling and an API standpoint, and also how to deploy both a stateless application, hello world, and also a very stateful application, Sql Server, right? We upgraded Sql Server, we crashed Sql Server, we deployed Sql Server, we tried to upgrade Sql Server. We did that all in a matter of a few minutes with a couple lines of code, which I think is quite dramatic if you consider that against how we've deployed Sql Server in the past with things like PowerShell and DSC and other deployment methods, which are, I think, a lot more challenging than being able to do things this way. So I'm fortunate enough to have the first session in the general set of sessions, which means I can party the rest of the weekend. But my friends Hamish and Bob Ward have other sessions on Kubernetes this week, so please go see these guys talk about what they're doing with Kubernetes. Hamish has a lot of experience at a DevOps universe, and he's going to talk to you about running containers in Kubernetes inside of Azure. And then Bob's going to do the Bob Ward thing and kind of dive deep into how this all works inside of Sql Server and how it all pieces together. And so those 2 sessions are available then. Amit Banerjee has a session on Azure Arc at 8 a.m. on Friday as well. I'm going to try to figure out how to be in 2 places at one time, but we'll see how that goes. From a resources standpoint, I talked about Docker for Windows, right? When I talked about, hey, you can use this configuration because you don't have to use my NFS storage, right? If you have Docker on your laptop, you have Kubernetes. You are a 1 checkbox away from running Kubernetes on your laptop. You go right-click on the Qt whale, you hit Preferences. Inside of there, you'll have a tab with the Kubernetes logo. You check the checkbox. You'll be able to run these demos within a few minutes once the containers download. Managed service providers, all the big fish have a managed Kubernetes offering, AKS, EKS, and GKE. I've been working with AKS for a while, and that works pretty good in the paradigm. There's some performance things I wish were a little bit better, but if you want to geek out about that, hit me up after the session. I am a Pluralsight author. If you want to build your own Kubernetes cluster, check out that course there. Free stuff here. I'm not trying to sell you this course. I literally want you to have access to this content. So you have free trial cards to get access to that course, or any course on Pluralsight, but please watch mine. And then also I talked about the past HDR VC video where I talked specifically about how to run Sql Server in Kubernetes. Today we kind of talked about big picture topics and how to run, or how just to use Kubernetes. That's going to go in the configuration. Resource management, talked about CPU and disk and things like that. And also backups and how you actually operationalize Kubernetes or Sql Server inside of Kubernetes. So if you need any more information, I'm going to have my debug demo up in a few minutes on GitHub, available to you. That's my contact information again. Please follow me on Twitter. And if you have any questions, shoot me an email. And thank you all so much for coming.